So now, I have the pleasure to introduce our next speakers, Chris Xie and Anna Hermansen. So Chris is head of open source strategy at Futurewei, and Anna is ecosystem manager at LFE Research. And Chris and Anna will share how Futurewei, LFE Research, and LFE Energy are collaborating on innovations that are transforming the energy sustainability. So please, the floor is yours.
Let's go to the first page. All right, this is the one. Okay, so my name is Chris Xie. I came from San Francisco Bay Area, the home of Silicon Valley. I'm right now working at Futurewei as a head of open source strategy. Today, I'll be sharing with you our vision on energy sustainability from the ICT perspective. So I brought something from California. Anybody know, kind of guess what this is? That's correct. This is a piece of shingle that was fallen from my house roof. So early this year, California had experienced a series of very strong winter storms. They call it atmospheric river events and bomb cyclones. So those strong winds, like damage houses, blown off the trees, damage a lot of properties within California. And the picture on your left is my roof that was ripped up by the bomb cyclones. And I took a video actually across the street of my neighbor. That's the video on your right. You can see this 20 meter tall California palm tree is blown so slanted that it will be unimaginable if those trees are fallen and how much damage it will cause to the communities. So climate change is getting personal. And our house during the storm lost power for 3 days. And some of my neighbors lost power for a week or more. So what will the energy future look like with pervasive AI and ICT? So according to Digital Information World, by the year 2030, there will be 21% of energy consumption will be from ICT sector alone. And it is equivalent to about 4 times more energy consumption than it was in 2010. Early this year, Stanford University issued an AI index report, 2023. In the report, it says that the training of OpenAI ChatGPT-3 emits about 500 tons of CO2, which is roughly equivalent to 56 years of carbon emissions of an average American home. It is also equivalent to about 110 cars running for a year. The report concludes that AI is both helping and harming the environment. Bell Lab research shows that as we move from 4G to 5G to 6G pretty soon, as network capacity increases, the power consumption increases significantly. So mobile networks, cloud computing, AI are foundational infrastructure technologies that present both significant opportunities as well as systematic challenge to our energy future. Therefore, it requires a systematic approach to address those challenges. So our approach to meet those challenges involves three aspects. The first is to promote. We're promoting carbon-efficient algorithms, programming languages, zero-bit, zero-watt mobile networks. And we do that through open source and open standards. The second is to democratize access to sustainable energy solutions, such as open source microgrid or virtual power plant solutions. We believe these are the sweet spots that has huge potential to fundamentally change the energy landscape of the future, that provide true energy sustainability, energy freedom, and energy security to the masses. The third is to collaborate. We believe that climate change is a global challenge that requires a global solution. And that is why we were, early this year, we were working with Landes Foundation Research on a study of global open source collaboration. On the networking side, they're working to promote adoption of NCI, the network carbon intensity standard, which was issued by ITU, the International Telecom Union Organization. So NCI helps network operators measure and monitor carbon efficiencies of their networks. So on the software side, we are engaged with Green Software Foundation on SCI, Software Carbon Intensity Specification. So SCI helps developers to measure the carbon efficiencies of their software systems. And we would like to go one step further to work with open source organizations, academia, to define our workbench workload or standardized workload or standard that translate SCI scores into social cost of carbon. The whole point of doing this is to really make SCI scores has real-life meaning in dollar terms, to help developers to determine their social cost of carbon dollars when they are deciding to use which type of language or which sort of set of software to implement their solutions. So on the democratizing sustainable energy solutions, we started out by working with Landes Foundation Research and Landes Foundation Energy on open source microgrid. And later on, Anna will share with us the results of those research. So if you are familiar with cloud computing, you may know that Kubernetes is a flagship open source project. If you are familiar with mobile networks, you may know that ORAN is an open source project that anybody can take and build their own mobile networks. But it's kind of hard to find such a flagship open source project on microgrid or virtual power plant. So our idea is that to work with communities, startups, open source organizations to incubate such an open source project in the hope that it will become a flagship project that will truly realize the vision of energy sustainability, energy freedom, and energy security to the masses. So we know that climate change is real. It is a global issue that requires a global solution. And we believe that open source is a great way to make that happen. We also believe that open source is a collective wisdom of all mankind. It is a shared knowledge base for us all. And that is the reason we're working with open source organizations globally, and also working with, starting with the Linux Foundation Research on the study of a global open source collaboration. So our hope is that in the future, there will be less and less such damages from climate change, as you can see in the picture. And we have done our little part to meet those challenges. So my challenge to you today is, what will you do to combat climate change? And that is all for my presentation today, and thank you for your attention. Next, I would like to introduce Anna Hermansen from Linux Foundation Research to share with us on our collaborations and other research projects. Thank you.
Hello. Okay, that works. Thank you so much, Chris. Thank you to Linux Foundation Energy. And merci Arthur pour nous accueillir ici. Je suis honorée d'être ici. J'adore Paris. So happy to be here in Paris. And to be talking to you all today about Linux Foundation Research's collaboration with Futurewei, with LF Energy on generating evidence-backed insight into the ways that open source can support the transition to cleaner and more democratic energy. I think I pressed this button. No, I don't. That's forward. Ooh. Do I press this green one? That one. Thank you. Okay. All right. So for those of you who are less familiar, LF Research explores the growing scale of open source collaboration. We generate insight into emerging technologies, to best practices, as well as we use qualitative and quantitative methodologies to support these emerging trends in our research. We do so by leveraging project databases and networks, and we also leverage qualitative and quantitative methodologies to generate the go-to repository of open source insight that organizations benefit from around the world. We use our research to inform decision-making and prioritization around the activization of resources in this sector. You can find all of our research at linuxfoundation.org/research. Since our inception in 2021, we've published over 30 reports, ranging from the carbon footprint of NFTs and the Web3 space to mentorship and diversity in the ecosystem. All of our research is backed by empirical methodologies. Some are survey-based, some are qualitative or interview style, and all of them include a written report of our findings, infographics that summarize key highlights from our research, and we also, if it's a survey, we publish all of our data in an aggregated, anonymized way, in an open way on data.world. We run all of our research across a number of dimensions, so that could look like a technology horizontal, an industry vertical, geographic segmentation, and then also at that ecosystem level. And it's at this ecosystem level where we address sustainability research questions, because often these questions run across industries, across technologies, across geographies, and really requires that multi-stakeholder approach. So, as Chris mentioned, we recently collaborated with Futurewei on a report that was just published yesterday on our website, the Open Source Opportunity for Microgrids. In this, we asked the research question, what is the state of open source in the microgrid sector? How might open source support the adoption of microgrids, support the microgrid sector generally? And what are some challenges to adoption in this space? And so this report was a collaborative process. We partnered with Futurewei, LF Energy, and researchers and advisors to get at these research questions. And we also worked with subject matter experts. We interviewed 17 of them, and the findings from that research was published in a report, which you can access on the QR code. So I'll take you through a few of those findings. There's more. Feel free to read more in detail. But first of all, the open source in the microgrid sector is still quite nascent, and yet it has a ton of potential to democratize, standardize, and better integrate all of these varied technologies that go into a microgrid. Open source does this by its consensus and collaboration, and so from this approach, it fosters the creation of standards and technologies that can better interoperate with one another. Open source also enables new business models, security, talent pipelines, and cost reductions. Open source is often cheaper than the proprietary or closed source opportunity in microgrids, and also creates a pool of resources that individuals can go to for knowledge generation and better adoption of these technologies. So for better adoption in this space, as it is quite nascent, one important thing is to support energy incumbents as they aim to adopt with the economic hurdles that are involved and the uncertainty in this sector. We could do this through data sharing, through education, and through goals alignment. And finally, policy needs to revamp. Right now, it's very focused on the centralized grid infrastructure, and educating policymakers and regulators on the microgrid sector and open source will help further the adoption of open source in this space. So there are more findings on this report, but I'll switch now to our second report, which was also published this week. This is the 2023 Energy Transformation Readiness Study. And in this one, we partnered with LF Energy to understand, or to ask survey respondents, which went out to utilities operators, what their understanding of open source is, and particularly when it comes to how it could support a transition of the energy grid, and also how it can help us meet our carbon targets more effectively. We also wanted to map out what the gaps are in transformation readiness and what kind of educational tools are needed to be put in place to better support grid operators, regulators, and other stakeholders to onboard renewables. So again, a few key findings. Our survey respondents understood that digitization is crucial to decarbonization. This is because it enables features such as smart home energy management, EV charging, and a more dynamic demand response. The picture of digitization is actually quite strong. Over 3/4 of our survey respondents have a clear strategic plan to reach digitization targets and actually have it already implemented. The main benefits that our surveys responded when it came to open source software is the cost reduction it provides and the speed to market time. Time to market speed. So this actually meant that our survey respondents said that they used open source more often than closed source. And of course, there are some barriers to adoption in this space. The majority of our respondents, when it came to barriers, pointed to concerns around performance of the software, whether or not the software was secure and reliable, and what kind of vendor support there would be when implementing the software. And so we really need to address these key challenges by educating and creating resources around adopting open source in this space. So I hope this serves as a call to action, as Chris said, to come together and to collaborate on our research questions. This opportunity for me to speak today serves as a knowledge translation, but also a reminder that we have all of these resources on our website, and we want individuals such as yourselves to use them, to take them back to your organizations, and to provide evidence around why someone should adopt open source in the energy sector and beyond. So please feel free to go find all of our research on our website or come talk to me after. And if you have a research question, we're always interested in collaborating and having a lot of voices in the room when we research. So please feel free to reach out to us. Thank you so much.
Thank you, Chris and Anna, for these insightful presentations. Indeed, a huge part of our challenge is at the crossroads of the ICT and software technology and of the energy industry. And on one side, in the energy industry, we need innovative solutions to have the energy transition and perform it efficiently. And on the other side, there are huge stakes on the ICT industry to decarbonize the energy consumptions and to be more efficient. So the works that you have presented are great contributions in that respect. And also what I like is that all these messages that you told us echoed with Mark said previously, that open source is most probably the best way to achieve this vision.